video clip, I am going to show you how to calculate for the ratio of dihydrogen phosphate and hydrogen phosphate to produce a buffer with pH 6.2. And from the calculated ratio, we are going to calculate for the volume of each of these ions to produce a buffer with pH 6.2. And the volume of this buffer is 50 ml. Okay, so we have to know that we have a buffer system. Okay, and then our buffer system is made up of dihydrogen phosphate and hydrogen phosphate. So from these two, this one is our acid and this one is our conjugate base. So we can represent this one as our HA and this one as our conjugate base A-. So our ultimate problem here is how much is the volume we need for our dihydrogen phosphate and how much volume for the other. So we are going to write the henderson-hasselbalch equation, which is pH is equal to the pKa plus log of A- over HA. So the required pH is 6.2. And the pKa for dihydrogen phosphate, for the acid, is 7.2. So we have log A- over HA. So we transpose 6.2 minus 7.2, that will be equal to log of the conjugate base over the acid. So our equation will be simplified into 1.0 equals log A- over concentration of the acid. Okay, so to get rid of this log, so we write 10 raised to the power negative 1.0 equal to 10 raised to the power log of the conjugate base over the acid. So this one cancels out. This one is, so the equation is simplified into 1 over 10 because 10 raised to the power negative 1 is 1 over 10 equal to the concentration of the conjugate base over the concentration of the acid. Okay, we need to recall that molarity is equal to the number of mole over liter of the solution. So if we are going to apply it here, so this equation will become the concentration of the conjugate base will be equal to the number of moles of the conjugate base over the liter of our buffer solution. Over the same goes with the acids. It will be mole of the acid per liter of the buffer. And since we know that all of these two will be in the same buffer solution, so the liter of buffer solution cancels out, and then the equation will be simplified into 1 over 10 equal to the number of moles of the conjugate base over the number of moles of the acid. Okay, so we have to carry on with the equation, the previous equation. 1 over 10 is equal to the number of moles of the conjugate base over the number of moles of the acid. So we can recall, if we have liquid solutions, we can calculate for the number of moles of the conjugate base by multiplying the molarity of that conjugate base times the volume of the conjugate base, which is also true for the acid. So we have molarity of the acid times the volume of the acid. Okay, so we have this 1/10 equal to molarity of the acid conjugate base times the volume of the conjugate base over the molarity of the acid times the volume of the acid. And since in the given problem, the molarity of the conjugate base is also equal to the molarity of the acid, that means these two cancels out, and our equation is simplified into 1/10 equal to volume of the conjugate base over the volume of the acid. Okay, so our running equation will be 1/10 is equal to the volume of the conjugate base over the volume of the acid. Okay, so from this equation, we can say that for every 1 part of conjugate base, you have 10 parts of the acid. So from this ratio, we can get the total volume of buffer in 1:10 ratio, and that would be volume of A plus volume of HA is equal to volume of the buffer. Now substituting, we have 1 ml, say 1 ml plus 10 ml, that will give us a total of 11 ml. And since our problem is to make a buffer which is 50 ml, so we are going to calculate for the volume of the conjugate base and the volume of the acid to form 50 ml of the buffer. So to do this, we use ratio and proportion. So we say 1 ml of the conjugate base for every 11 ml of the buffer. So how much volume of A we need if we want 50 ml of the buffer? So calculating for X, we will have 50 over 11, which is 4.5 ml of the conjugate base. Now, since the total volume of the two is 50 ml and A is 4.5, so we say 4.5 ml plus Y is equal to 50. To calculate for Y, so we say 50 ml minus 4.5 ml, which is due to conjugate base. So Y would be equal to 45.5 ml, which is now the volume of our acid. So therefore, for buffer solution which is 50 ml, we need to prepare 4.5 ml biphosphate and 45.5 ml dihydrogen phosphate. And these two will add to our 50 ml of the buffer.